Question 10 then is testing our understanding of the normal distribution. We are given information on the masses of watermelons grown on a farm and told they are normally distributed with a mean of 10 kilograms. They're classified as small, medium or large, and we know that a watermelon is small if its mass is less than 4 kilograms. And it tells us that 5% of the watermelons are classified as small, and in part A we are asked to find the standard deviation of the masses of the watermelons. So let's try and recognise what we've got here. We've got a random variable here, x, which is the mass, and we know that that is going to be normally distributed because it tells us with a mean of 10 kilograms and a standard deviation which we don't know of, sigma squared. So we're told that the probability that it is less than 4 kilograms is 5% or 0.05. So this is going to be our starting point. Here we are going to have to use the standard normal distribution. So if we think back to the formula for the standard deviation, and remember we use the letter Z to represent that, we can say that we can find the standard distribution by using the formula x minus mu over the standard deviation. So if I substitute that into here, the probability that Z is going to be less than 4 minus 10. So 4 is here, the weight of the small kilograms. Subtract 10 as the average, all over my standard deviation, which I don't know. But I know by standardizing it that this probability will equal to 0.05. Because if we remember, the standard deviation is the same shape. And all I can do is I've got a mean here of 10 and a standard deviation of some value which I don't know, but I can standardize it onto the normal distribution which has mean of 0 and a standard deviation of 1. So that's what I've done here. Now I can, with my calculator, find the inverse normal distribution for 0.05, and if I do that, that gives me a value of negative 1.645, which would make sense because if you think about it, here the mean is 0, so the area down here on this in this kind of tail here you would expect to give me a negative value. So all I'm left with then is trying to figure out the standard deviation by solving 4 minus 10 over sigma equals negative 1.645. And if I solve that, I can find then that the standard deviation is 3.65. So the key then to this question is recognizing that even if we don't know what the standard deviation is in a particular normal distribution, and we've got the mean and the other variable x, we can standardize it and then work backwards from the standard or the inverse of the standard normal distribution in order to solve. So that is part A. So in part B, it tells us that a watermelon is large if its mass is greater than W kg. We're asked then to find what this value of W is. So bearing in mind in part A we found the standard deviation. In part B then we can just write our distribution. We can say x is normally distributed with a mean of 10, and we can just put in the standard deviation here of 3.65. So we don't need to use the standard normal distribution here. We can just go ahead and use our calculator. So we know that the probability that x is greater than W is equal to 0.38. So we've got something like this, and there's some value here, W. We know that the mean is 10. So in effect, we know that this probability here is 0.38. But remember, if we're going to work out the inverse normal from our calculator, we need to know the area to the left of a boundary. So this region here is going to be 0.62. So this is the value that you're going to put into your inverse normal to calculate that the weight will therefore be 11.12. So that's taking this value and knowing the standard deviation and mean and substituting into the inverse normal function on your calculator. Relative to parts A and B then, part C was fairly straightforward, and this was the one that a lot of people picked up on even if they didn't get any other points from this question. So we are told that all of the medium and large watermelons are delivered to the grocer, and the grocer selects a watermelon at random from this delivery. Find the probability that it is medium. So for this, you need to look at the probability of getting a medium, which we said was 0.57, and then this is going to be divided by the probability of getting a medium or large, which was the total, and if we solve that, we end up with a value of 0.6. For part D then, we are looking at a kind of economic interpretation of the significance of this question. So we are told that the grocer sells all the medium watermelons at $1.75 each, and he sells the large watermelons for $3 each. We're told that his costs for delivery are $300 and his total profit is equal to $150. And we're asked, therefore, to find the number of watermelons in the delivery. So, to do that then, we need the probability of getting a medium watermelon, which we worked out from the previous question, was 0.6. So the expected income from sales of medium watermelons will be the probability of getting a medium watermelon multiplied by the number of watermelons, which we can call X, and then if we multiply that by the cost of the medium watermelons, that will tell us the proportion of the sales of medium watermelons. To that we can add the probability of getting a large watermelon, which will be 1 minus 0.6, multiplied by the number of melons sold, multiplied by the cost of the large watermelons, which is 3. And this will give us, in effect, the income. From that, we can subtract the expenditure, which we know is the delivery cost, which is 300, and that will give us the profit, which is 150. So you can see the only unknown in this is X, which is the number of watermelons in total. So this is telling us the proportion of medium watermelons, this is telling us the proportion of large watermelons, but we've only got one unknown, which is the total of watermelons. So if you solve this equation, you will end up with X equals to 200. So the number of watermelons in the delivery was therefore 200.